Hello, welcome to the Mathematics 23 review. In this video, we will talk about vector fields, curl, and divergence. So let's recall some definitions. This is the del operator, or simply del. So this is a vector consisting of partial derivative operators. So this one is for the 2D case, or two-dimensional case, and then this is for the 3D case, for 3 dimensions, okay? Now, the divergence is defined as the dot product of del and f, and the curl of f, a vector field pala, is the cross product of del and f. Okay? It is important to note that del and f should have the same number of components, okay, each. So, if this is 2 dimensions, this should be of 2 dimensions, and vice versa, okay? If 3 dimensions, this should be 3 dimensions, okay? The divergence is a scalar or a real number, and the curl is a vector field, okay? So now we try out some examples, okay? So this is our first sample problem. So we have the vector field, and we are asked to find the divergence and curl of f at A, okay? So the dot product, how do we compute this? We perform component-wise multiplication and then get their sum, okay? This is the partial result. Pun slightly intended. Okay? Now, in case you have forgotten how to perform partial differentiation, you may refer to our previous videos on partial differentiation, okay? So we have this one, okay? And then substitute, okay? X is equal to 1, Y is equal to 0, and Z is equal to 1, so that we arrive at this result, okay? 5 over 2 plus ln of 2. So this is the divergence of f, okay? If f is of 2 dimensions only, so you may omit this, okay? And then ayun, dot product lang, okay? This is pretty straightforward. So, okay, we proceed to the next sub-problem, sub-item. So we get the cross product this time, okay, to get the curl. So the cross product is this one. And how do we get the cross product? So first, to get the first component of our curl, we just cover up the first column, and then we proceed to cross multiply, and then get their differences, okay? So this one minus this one, okay? So partial derivative minus partial derivative, okay? For the second column, now the second column is a bit special, so cover up the second column for the second component. So how do we do that? We obtain the cross product. We cross multiply. Sorry. Okay. And then we get their differences. So partial derivative minus partial derivative and then times -1. Ayun. Yun yung extra step. That is the extra step. So you need to multiply a -1, or we affix a negative sign at the difference. Okay? So minus or negative of ito, okay? Minus ito. Okay? Joke lang. Okay. So, ayan. Yun yung second component. For the third component, ayan. This is now similar to the first component, to obtain the first component. Okay? So, we cover up the third column, and then the usual, ano lang, cross multiplication, cross multiply. Okay? Ayan. Here. Okay? Partial derivative minus partial derivative. Okay? So now we have this one. Okay. For those of you who are familiar with linear algebra, this is just cofactor expansion along this row. Okay. Along the first row. So now we substitute. Okay. Ayan. Done. Okay. If in case your f is of two dimensions only, the most convenient way is to omit this. So, okay, mawawala lang to. Ayan, hanggang two components lang. Ayan, hanggang dito lang. Kunwari wala kayo nakita dito. Ayan. Ayan. Then, uh, cross na multiply. Okay? But you will not subtract. Okay? So, this is the first component. Okay? Partial derivative of this one. Okay? First yun, first component. And then for the second component, ayan. Ito na yun. Okay? Again, you are not required or it does not involve any subtracting here if we are talking about the two-dimensional case. Okay? So, ayan. Now, we proceed to the second sample problem. Okay? True or false to? Okay? So, if f, sorry. Ito, proceed muna tayo. Ayan. If f is a conservative vector field, then the divergence of curl of f is equal to 0. Okay? Now, actually, this idea, this concept, will be further tackled in the next video. However, metagaming muna tayo. Advance muna tayo, okay? So, from a theorem, if f is a conservative vector field, then it should happen that the curl of f is equal to the zero vector, okay? Actually, this is an if and only if, but this holds yung if and only if, okay? Yung if, ayan. Okay, f, shortcut ko na lang f conservative. Ayan. F conservative if, ayan. This only holds if we are talking about F being defined on a simply connected region. Ano raw? Okay. Yung in-depth explanation ng simply connected region is beyond the scope of this subject. Okay? So you may refer to some resources or references in the internet on what it means to be a simply connected region. Okay? But basically, basta magandang figure, okay? Anyway, nakita niyo naman. Okay. But anyway, in calculus, this holds because all of our vector fields naman are on either R2 or R3. So no problem on verifying if this holds. Okay? So assume na lang na totoo because assumption in this course is that all vector fields here are from R2 or from R3. Okay? So okay. Now going back, so F is a conservative vector field. Then this is the zero vector, okay? And the zero vector is a vector field whose components are all zero. Ibig sabihin, yung laman niya, puro zero lang, okay? And then the divergence is simply the dot product of del and then F. In this case, our vector field is zero, is the zero vector. So the divergence of the zero vector is zero. Kasi partial derivative of zero is zero. So nag-add ka lang ng zero 3 times, 0 plus 0 plus 0 is equal to 0. So this is true. Okay? Totoo. Next. Let K be a real number and F be a three-dimensional vector field where F1, F2, and F3 are all scalar fields in R3. If all the scalar components of F, so F1, F2, F3, are polynomials in R3, then K times the divergence of the curl of F is equal to 0. Okay? So all of these here are polynomials. Okay? Now, recall that in your previous calculus courses, that a polynomial function can be differentiated many times, and the derivative still exists after you differentiate many times. So differentiable, but formally it is more formally known as ano, infinitely differentiable. So you can differentiate many number of times, and the all derivatives there still exist. Okay, so we try to compute the curl of f. Okay, verify, sige, verify that the curl of f, okay, curl f is equal to, uh, alam mo, text na lang. Okay? Well, I hope this is clear from context. Okay? So, the curl ay hindi blue. Okay? The curl is equal to this vector. Okay? f3y minus f2z, then f1z minus f3x, and then f2x minus f1y. Okay? So, partial derivative ng f3 with respect to y, partial derivative of f2 with respect to z, and then, ayan, similar reasoning lang. Okay? So, this is the curl. Okay? Now, since polynomials naman sila, they are polynomials, each of these derivatives exist. Okay? So, we have no problem naman. Okay? Safe naman. Happy, happy. Okay? Now, for the divergence, div f, yeah, divergence of f. Okay? Verify, again, verify. So, partial derivative lang ng first component with respect to x plus the partial derivative of the second component with respect to y plus the partial derivative of the third component with respect to z. Okay, so verify is f3yx minus f2zx plus f1zx, y minus f3xy plus f2xz minus f1yz. Okay, is this correct? Okay. Okay. So now, now since all of f1, f2, f3 are polynomials, the second derivative also exists. Kasi as we said earlier, all polynomial functions are infinitely differentiable. Okay? Differentiable many times. And then nag-exist pa rin yung derivative. Okay? Also, continuous yung partial derivatives everywhere. Ayun. Okay? By Clairaut's theorem, okay, hope you still remember that. Clairaut, French Clairaut's theorem, okay, states that if we change, no, if F1, F2, F3, okay, lagi ko na sa setting na to. F1, F2, F3 are all differentiable naman, infinitely differentiable actually. So that means their second derivatives also exist. First order derivatives also exist. First order partial derivatives exist. So here you may change the arrangement of the variables, okay? So f3yx is also equal to f3xy. Okay? So, okay, get ready. So, this cancels out. Okay? Pag nagsisimplify na tayo eh. By Clairaut's theorem, we can do this eh. Okay? Ito, and then ito. So, indeed, sorry. So, truly, this is equal to 0. Okay? Divergence is equal to 0. And then k, kahit ano naman, k times 0 is equal to 0. So, that means the statement number 2 is true. Okay? Ayan. So, true. Okay. Ay, hindi ko pa nabubura pa. Okay. Now, for the third item, sub-item, if phi is a scalar field with continuous second-order partial derivatives, then the divergence of the curl of the gradient of phi is equal to c for some c in the set of real numbers except zero. So non-zero real number is cc. Okay. Is this true? It is actually false. Why? Um, okay, we try to compute now. So remember, okay, for simplicity, without loss of generality, we set phi to be of two dimensions only. Yeah, para madali. Madali illustrate, okay? So if phi is of two dimensions, so it involves the partial derivative of x and the partial derivative of phi with respect to x and the partial derivative of phi with respect to y. So yun yung gradient, no? Okay? And then the curl of this, okay, yung curl ay, ano yung curl? Sige. Okay? I hope at this point, na-refresh na kayo on how to compute the curl. So, ito ay, shortcut ko na lang. Okay. Px, Py. Okay. So, this is phi of yx. Okay, in yung curl. And then, this is phi of xy. In yung curl. Ito yung curl, Ayan. Ito yung curl. Okay? Now, sorry. Ayan. Now, the divergence of this, okay? The divergence is, ay, dami. Dami ito. Divergence is simply phi x, y, x. Anyway, second, yun lang. Ano ba? Y, x, x, sorry. Plus phi x, y, y. Score. Sick na. Absensya na. Okay? Now, it only said that phi is a scalar field with continuous second-order partial derivatives. Okay? Actually, this, no, may implied meaning to eh. Yung first order din, continuous din. First order partial derivative. However, we cannot guarantee that the third order partial derivative exists or is continuous on the same domain. So not necessarily true because we don't have any information about the third order partial derivatives, okay? So it is false. Okay? So with that, this ends our video, okay? So thank you for listening and have a good day or a good evening.